Hello, I welcome you all. Now in this class, we are going to discuss about the coplanar and non-concurrent forces. Under this class, we will learn about moment, couple and varignon's principle, and also we'll solve one problem. So let's start that what is coplanar and non-concurrent forces. So as you know, in previous video we already discussed about the system of forces. So under that we have discussed what is coplanar and concurrent. So now combined form of coplanar and non-concurrent forces we are going to see. So coplanar means what? Coplanar forces is nothing but the forces which is acting on the same plane, right? If we have a same plane, means the number of forces are on the same plane, it is known as the coplanar. Non-concurrent means what? The forces which is not on the same line, right? Or you can say that does not lie on same point, right? On same point, right? So you can say coplanar and non-concurrent means what? The forces which is on the same plane but does not lie on the same point. So those forces are known as the coplanar and non-concurrent forces. So what type of forces, what are the example of the coplanar and non-concurrent forces? So you can see that you have a one rod is there, right, of having length is L. On this rod the number of forces are acting. So let's say that this force is like this force is like this force is like this, or maybe this force will be like this. So you can see you have a four forces, that is F1 of having magnitude, F2, F3 and F4. So these four forces all are lying on the same plane which is on the rod, but the F1 and F2 and F3, F4 are not on the same point. So this is the example of the coplanar and non-concurrent forces. You can see one more example, that suppose you have a one xy plane is there, right? So this is y-axis and this is the x-axis. So this one plane is there, that block is there. So on that block the forces will be like this, the forces will be like this, the forces is like this, right? And the forces will be like this, right now. So this is how, right? So let's say this is F1, this will be the F2, this is F3 and this is F4. If you observe that the F1, F2, F3 and F4 are on the same plane, that is on this block, on the same block, but the F1 is generating from here, F2 is from here, F3 is from here and F4 is from here. Means these forces are not concurrent, means these are not lying on the same point. So these are the coplanar and non-concurrent forces. So whenever the problem is come like this, okay, are basically the beam problems, right? So those are the case of coplanar and non-concurrent forces. Okay, now next we'll move to the moment. So what is moment actually? That moment, right? So moment is what? Moment we are denoting by m, its unit will be the Newton meter. Okay, so moment is what? That moment is nothing but, you can say the moment is a force into perpendicular distance, right? So force into perpendicular distance, simply force into perpendicular distance is a moment. Or you can make a one more point, that moment causes rotation, right? So if any body is there, right, if the body is having rotation, that rotation is because of the moment only. So moment, we can say the moment is causes rotation, right? Moment is causes rotation. Simple example of moment that causes the rotation means what? Your opening and closing of a door, right? So we have a handle, and about the hinged point the door has to be open or closed. So whenever you will pull or push, so means the force you can apply perpendicular, right, and along the horizontal direction, means along the horizontal length. So because of this product of the force and the perpendicular distance, will create the moment and causes the rotation. So if you see that mathematical how the moment we can get, right? So again we can say one rod is there of having length is L. Okay, so let's say that length is L and these are the 2 points. That is, this point is A and this point is B. Okay, now so if the force is acting vertically downward on the point B, so you can see simple this example, that is, this is your A and this is the B. So here I am holding it, means suppose this is the hinged and you are applying the force, from this side, right? That is vertically downward from this, see the finger. So how the rotation will take place? Force you are applying perpendicular and the distance is horizontal. So this distance and force are perpendicular, so the rotation has causes, right? So the body is rotating in this fashion right now. So it means that when you apply the force like F, so it will be rotated in the clockwise sense. Just now you have seen, right? So moment, and it is rotating about which point? About A. So you can say the moment about A is equal to F into L. All right, okay. Now the next one more case, you can see that this is like this, right? This is point A and this is the point B. So this is the point A and this is the point B. The force is acting in the vertically upward direction and the length of the rod or element is L. So now see, this is the element or rod, this is the point A and this is the point B. So here is the hinged point, suppose this is the hinged and I am applying the force like this. So perpendicular force and the distance is like this, right? So if the force is horizontal, the distance should be perpendicular. Here you are applying the force perpendicular, so the distance is horizontal. So each means distance and force should be perpendicular to each other, right? If the force is like this, and then the distance should be like this, is it or not? Then rotation will takes place. So here the distance is along horizontal, so force will be perpendicular. How it is rotating? You can see the rotation is along the anti-clockwise direction, right? So this is, you can say F, and the rotation will be like this. So moment about A is what? That moment about A is equal to, again you can say F into L, right? So it means that on this discussion you can say the moment is of two types, right? What are those moment? That is clockwise moment, okay, and anti-clockwise moment, that is counterclockwise moment, right? Now so just for the understanding, that clockwise moment we will take it as a negative, right? And the counterclockwise means anti-clockwise moment will take it as a positive. So this is the sign convention for the moment, right? Okay, now next we'll move to the couple. Here only. So next we have a couple. So couple is what? That couple is nothing but that couple, simple couple meaning you know, that is the pair. Okay, so couple is what? Couple is nothing but if two like forces and two parallel and like forces, right, are separated by a distance, they create the couple, right? So you can say that two like and parallel forces means what? The two forces are like this, right? This is this like forces means what? The same same magnitude, right? So this force is in this sense and this is like this, right? So they are having same magnitude and these are the parallel. So let's say that force is F1 and again this force is F2. That's the magnitude is, sorry, this is also F1 right now. So that they are separated by a distance of D, so they form the couple, right? So couple you can denote it that C and the unit will be same, it is like a Newton meter, right? So couple is equal to what? C is equal to F into D, right? So you can say the couple is what? Two parallel forces equal in magnitude and opposite in direction are separated by a distance are said to form a couple, right? So next you have a Varignon's principle. This is very important, that Varignon's principle, based on Varignon's principle we have a number of problems will come, right? So you can say the varignon's theorem. Actually, it's not a principle, right? So as you remember that while we study the system of forces, in system of forces we have discussed that how to find out the resultant and the direction. So the resultant formula, that R is equal to root over of summation fx square plus summation va square, right? That is h square plus va square. Okay, now suppose any system of forces is given to you. Let's say that system of forces is given to you like this. This is one rod is there. Okay, so you can say any length is there, like this length is, let's say it is L, right? Now so here you have a one point A and here you have a one point B. That name of the rod is AB. Okay, so number of forces are acting like this. Let's say this is the F1, this is the F2, right? This is the F3. Okay, and let's say this is also one force is there, right? So this is F4. Anything you can consider. Now so these are the distance. Let's say this is D1, D2, D3, or X1, X2, X3, right? Now so by using these forces we will get the resultant. Let us say the resultant is R of this system of forces. Very carefully try to understand, that is this resultant is R, right? Now the resultant value we already calculated by using the empirical relation, right? Now we want to know that where this resultant is lying, means what is the position of the resultant. To get the position of the resultant we apply the varignon's theorem. So how can we apply that? Now we need to consider that, you can say, let us consider the resultant is at a distance of x, right? Resultant is at a distance of, or it's better that x naught, you can say the resultant is at a distance of d. From where? From A. You can consider from B also, there is no restriction. So I am considering that the resultant is at a distance of d from A. So this is the resultant which is shown, this line is there now. So this is the resultant, right? So I am considering the resultant is at this much of distance from A. So now what should I do? This resultant, that is resultant is a force. So force into perpendicular distance will get the moment R into D, right? And this moment, because of the resultant about this point, should equal to the sum of all the moment about these forces, right? So what are the moment? Moment will get about these forces F1, F2 and F3 into distance, right? So their summation about this point of the moment is the varignon's principle. So you can say summation of MA, right? So this is the you can say the varignon's principle, right? So varignon principle is used to find out the position of the resultant, and what it says that it states that the sum of all the moment about that point, about a point, is equal to the moment of the resultant about that point. So sum of all the moment about that point means what? The point is A, right? So moment about this force, moment about this force and moment about this force, their summation should be equal to the moment about the resultant, that is R into D, right? Now so this is the varignon's theorem. Now in some cases we have to find out the x and y intercept of resultant, right? So you can say that x intercept of resultant, right? X intercept of resultant, x intercept of resultant, right? So when you have to find out the x intercept of resultant, so what is the formula for finding the x intercept of the resultant? You can say summation of MA, means about any point, you can choose from B also, right? MA by that is resultant about the y-axis. This is the x-intercept, right? That is x-intercept is equal to summation of MA about RY, means what? Whatever the resultant you'll get about the y-axis, if you divide, you'll get the x-intercept. Again for y-intercept, just reverse that summation of MA by Rx, right? So on this concept you'll get some problem also in your paper right now. So based on these discussion we are going to solve one problem. So we'll get the means practical idea, right? So we have a one yes, this problem only, right? See, you can see the problem on the screen. We have already written the problem, right? So I'm dictating. Once you read, see, the system of forces acting on a bell crank is shown in the figure. Find the magnitude, direction and point of application of resultant. Point of application of resultant means what? That position of the resultant you can find, right? So if you look at this figure, so how many forces is given, right? So see, these one force, 2, 3, 4 forces are given. So this magnitude is 500 Newton, right? So if you see, this 500 Newton is, arrow is downward and it is inclined with 60-degree inclination. At this point, the vertically downward of having magnitude is 1000. Again, this vertically downward, which is having magnitude, is 1200, and the horizontal towards left is 700 Newton. If you see, this crank is inclined by an angle of 60-degree at the point O, right? So first of all, we have to find out the magnitude. For finding the magnitude, the simple R is equal to root over of summation of fx square plus summation of fy square, right? So now you can say that resolving the forces horizontally, okay? Resolving the forces horizontally. So quickly you can find that summation of fx is equal to what? It is going right. Why? Because arrow is like this. So horizontally it goes towards the right. So it is what? 500, and inclination with the horizontal. So horizontal component is cos. So cos 60 degree. This is vertical, we need not to take. It is also vertical, we won't take. And this is the 700. It is exactly horizontal towards left. So it will be minus 700. Okay. Now you can get the summation of fx value, right? Then I'll put this value later on. Now we can say the resolving the forces vertically, right? Resolving the forces vertically. So vertically means what? That summation of fy. So how many vertical force? Its vertical component, which is acting downward, 1000 vertically down, and this is 1200. These all are down, right? So you can say minus 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 right now. So it is what? Minus 500 vertical component is sine. Why? Because inclination with the horizontal. So 500 sine 60 minus 1000 minus 1200. Okay. Now, so value is what? That it is minus 450 Newton. See, you can cross check. Why? Because maybe there is a human error, right? So you need to cross check right now those values, and this will be the minus 2633.01 Newton. So summation fy. Okay. Now then simply you will impose that relation, that resultant R is equal to root over of summation of fx square plus summation of fy square. So it is what? Root over of minus of 450 whole square plus minus of 2633.01 whole square, right? So we'll get the resultant as 2671.19 Newton. So this is your resultant. First question we done. Next we need to find out the direction. So direction, how we get that direction? Tan theta or alpha, whatever you can say, tan alpha is equal to summation of fy by summation of fx, right? So alpha is equal to, see here, alpha is equal to tan inverse of fy is what? Fy is minus 2633.01 upon minus of 450. Minus minus will get cancelled, and the direct alpha value will get, that is alpha is equal to 80.3 degree, right? So now you can say that this is how your problem right now. So if you want, you can copy this. Right now, main thing we have to find, that is the position of the resultant, which is the point of application of the resultant, right? So point of application of resultant, here only I'll show you that. Let us say the resultant is a what? Resultant is R, is it or not? So this resultant I am considering that resultant is lying at a distance of where? Anywhere you can locate from O, right? So here that let us consider the resultant, this is the resultant, R is at a distance of D from the O, right? So this is the point of application, which is this is at a distance of D from O. So now what we should do, we'll apply the varignon principle. So varignon principle means what? That moment about that, means the moment of the resultant about that point is the sum of the moment about that point. So sum of the moment about that point means what? The moment about this force, moment about this force, moment about this force, and moment about this force. Okay, now their summation should be equal to R into D, and we are finding moment about what? Moment about O. So now we can write first a statement that it's better to take the new page. We'll show this, right? Okay, so just wait. This page we are keeping as it is. And one more thing, that you people please try to watch the whole videos, means till end right now, so you'll get the concept. Why? Because at the beginning means sometimes people are thinking that this video is not useful, but when you enter into the videos, means after 5 minutes or 10 minutes you'll get the main topics, right? So that things is happening in your classes also. So try to be watch whole videos, right, and complete videos. Now we can say the consider, yes, let us consider the resultant R is at a distance of D, is at a distance of D from O, right? So we can say that summation of M about O is equal to R into D. This is your varying principle we have. Means what? Whatever the forces is given in the system, that this is your system, right? So this is your system. So 1, 2, 3, 4 forces. We'll find out the moment about this, and that is equal to R into D. That is the varignon principle. So moment, if I take this moment about O, right? So this force is inclined. So it means that we'll get their component, the horizontal component like this, and the vertical component is like this, right? So if I take this component, that is horizontal component, we don't have any perpendicular distance. The condition for moment is what? The force into perpendicular distance. If you have taken the forces as horizontal, you need to be, distance should be perpendicular. So if I take horizontal, we don't have a perpendicular distance. But if I take this vertical component, we have this distance which is perpendicular to each other. Now this is vertically downward, so the horizontal distance, right? This force is vertical and the distance is inclined. So this distance is inclined, it means that you'll get their component, horizontal component and vertical component. So for vertical force, the distance is horizontal, and for horizontal force, the distance is vertical. So its vertical component is what? Its vertical component is nothing but this distance. Vertical component is 150 sine 60, and its horizontal component is 150 cos 60, right? Its horizontal component is 500 cos 60 and vertical component is 500 sine 60. All right. Now, so if I take this whole length, so its horizontal component is what? That is 150 plus 150, 300 cos 60, and the vertical is 300 sine 60. All understood? Now, so directly I am writing that imposing this relation into that equation means what? That, and one more thing, that if I discuss you the direction, if I take this force, that is, let's say this, vertically downward, okay, so this is the vertically downward, and the point is this one, right? So this is how, that this is like this, and the force you are applying like this. How the rotation will take place about this, about my finger, that rotation will take place anti-clockwise, right? Again, about this force, that is 1000 Newton, so anti-clockwise, right? But if I take this vertical force and this distance, right, so how it is, that means this is also clockwise, right, and this will be the anti-clockwise, is it or not? So you know the moment is clockwise is negative and anti-clockwise is positive. It means that moment about this and this will be positive, and this is the negative. Why? Because it's give you the clockwise rotation. Okay, now so you can say that is moment first, 500 sine 60 into 300 plus 1000 into 150. Simply that 1000 is vertically downward, you can refer the figure, minus this is 1200 is vertically downward, and the distance was like this, 150 with inclination of 60 degrees. So 150 sine 60, right now. So it is what, 1200, 150 minus 1200 into 150 sine 60, right? One more force is there, that is plus continuation, right now, plus 700 into 300. This whole length is what, 150 plus 150, 300, and its vertical component is sine 60 is equal to what, r into d, right? R is what, 2671.19 into distance, right? You can simplify. So d is equal to what, this whole by 2671, right now. So you can get directly distance is equal to 141.19 millimeter. So this is the point of application of the resultant. So where is the resultant? So resultant value, you can say d is equal to 141.19, right, 19. So this is like this. Okay, so this is how we will solve the problem, right? So now in the next class, means in upcoming video, we are going to solve more problems. The problem is a combination of Lami's theorem, that varignon's principle, and the resultant. So please subscribe, like, and comment the videos, right? Thank you.